So wow, nice turnout. Thank you for coming. So this is sort of an advanced HTML5 talk. I'm going to focus more on performance of HTML5, sort of what you need to consider for building web applications in HTML5. Ernest later on in the day is going to talk more about multimedia, sort of CSS, graphics capabilities of HTML5, whereas I'm going to focus on more of the technical APIs. So that's sort of the agenda that I just shared with you. Performance, we'll talk a little bit about web storage, what you can do to take your application offline using HTML5. Web workers and WebSockets for real-time communication performance. Tools and resources, some things you should be aware of when developing apps. And some compatibility concerns as well, because the sad story of the web today is, we're at a place we're better than we were 2 years ago, but we're still have compatibility issues on the web. So a little bit about myself. That's my Twitter there, ebidel@. I'm a developer programs engineer at Google. I've worked on a bunch of different products, worked on Docs, Google Sites, APIs, Google Health, Google Base. And now I work on Chrome and HTML5 with extensions with Ernest. Doing what I love. It's front-end development, it's client-side development, and Chrome is a fantastic platform for development, so it's really exciting. So let's talk a little bit about some performance techniques in HTML5. The first takeaway here is do not underestimate CSS3. So, we've gotten so used to developing web applications using libraries like jQuery and Prototype and Dojo for things like rounded corners and box shadows, reflections, alpha mass, and all these rotation capabilities. That's great, but now all this stuff is native to the browsers, so we don't have to have this huge download of a library, even if it's minified. As an example here, this is a CSS animation and transition. So just by defining a couple properties, the transition and the different prefixes for each browser, we can say I want to move this by applying a class, this particular div, from the left to the right, and just toggle that on and off, and it'll change, and the keyframes will be generated with the browser. We don't have any JavaScript to control that. A tip for you, using 3D transforms that translate 3D, you can move the same thing by 10 pixels in the x-coordinate. But that's going to actually fire in the GPU acceleration. So anything that has CSS 3D transforms will use the hardware acceleration. So it's going to be fast and performant, kind of like the demos you saw in the keynote. Some other things, there's new pseudo selectors in CSS, so use those instead of JavaScript. And web fonts, we'll see in a little bit, which are, beautiful typography on the web is finally there. We don't need images to have big, beautiful web fonts and logos. So another thing, we can go native now. This is in sort of the same line of the JavaScript and CSS. So there's new methods available to us. There's things like native JSON parsing. We don't need a library for that. There's things like new methods on the string class, so you can trim a string, the padding off a string. Some of these are popularized by libraries like jQuery and our popular libraries. For example, the query selector is a new thing in JavaScript 1.6 that's been implemented. And so you can use CSS pseudo-selectors to get at pretty much anything you want. Of course, how many people have used a library like jQuery? Okay, so we have some web developers in here. But that's all native to the browser now. You don't need a library to do that stuff anymore. And the last point on the slide is that we have things now that are becoming popular like data URIs. So you don't have to make that extra HTTP request and waste the user's resources and bandwidth. You can just render something, say, for example, a canvas. You can export that image to a data URL and then save that to the user's computer. So something else new is the class list attribute on HTML elements. And here's a simple example of that. So we have this main div, and I have a shadow class and a rounded class applied to it. And then using this new property on the HTML element itself, we can iterate over the different classes on this property. So again, something that you've done every day in web development on the client side in a web app, you can now do this native. So you can toggle the class on and off. You can see if it contains that class, and so on and so forth. I'll just lastly mention that it's not just web development and things like classes and whatnot. We also have native support for things like mapping on arrays and filtering by numbers and the for each method, which is again something popularized by the libraries, but now it's native, so we don't. It's going to be faster using the native implementation. So let's talk a little bit about some of the markup that you can use to build your next web application. Of course, Ernest is going to cover more of the semantic markups in his talk later. But one thing you should be aware of are the new REL attributes. So for instance, you have the REL for RSS feeds and Atom feeds, the alternate link, which will render sometimes an icon in the browser's URL bar. But there's two new ones. There's pingback and there's prefetch. So a good example of pingback is to notify a blog, your parent blog, that a subsequent blog is linking to that. So you can sort of inform that blog which sites are linking to it. Another good example is prefetch. So this example basically informs the browser that the user, there's a 90% chance that they're going to click on this next page. So think maybe a page of search results on google.com. You know the user might click that first link 90% of the time, so you can tell the browser to prefetch that page and cache it and get it ready for you. Another new addition to HTML5 are data attributes, which are really, really handy. So this is customized markup that you can write as a developer. So this example here, I'm using one of the new tags. It's an output tag. And I've defined 3 data attributes. I've defined data-ID, data-name, data-screen name. And I've set those to custom values. So I'm actually storing data on the DOM, which is pretty cool. And I can query for that using the same methods that you saw that I just discussed. But you have a whole sort of JavaScript API for this. So you can set them, you can get at them. You can iterate through the element.dataset and get the key value pairs. And this last bottom part here is what it would print out. Important point to note is that you see on the output tag I've set the ID equal to out, but my data attribute data-ID is set to good. And so when you're iterating through the data set, you're actually going to get the value of good instead of out. So it's not the element.id, it's the data set value of that. Another, I think, sort of underwhelming but very exciting part of HTML5 are forms. How many people have built a web form? Probably everyone. This is something that's needed much, much love over the last, 5-10 years. And HTML5 is really bringing this out. So instead of explaining this, I'm just going to show a nice demo of it. Whoops. Hopefully you guys can all see that. So the important point, and to remember when I'm demoing these, is that there's no JavaScript on this page whatsoever. This is all rendered natively in the browser using CSS and markup. So the first thing you see, I'll try to talk using this mic. Can we turn this one on? Testing? 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 Okay. The first thing you see is a couple new selectors. So I have the invalid selector here, which says if something on this form is invalid, apply that class. I'll just color the border color red, for instance. And you can already see that invoked right here in this name field. There's also a new required attribute or a pseudo-selector that you can use. Anytime something's required in a form, you can say, hey, maybe turn the background yellow. So as a first example, it's just an input equals text, but we have the required attribute. And since it's required and there's no value, it's going to be turned red. And you can see when I start typing in here, it immediately turns valid. So the required field is met. There's also a nice placeholder attribute that you can use. 90% of the JavaScript on the web probably does some kind of toggling of a placeholder. It does things like autofocus. All of this stuff is native now in HTML5, so you don't need a library or even JavaScript to do this stuff. Other new elements, there's a search element. And these are sort of how Chrome renders them. Other browsers render them differently, but you get the idea. Again, no widget library here. This is a range attribute, so I can set a min and max value, set a step size and a value, and I can scroll that. An email address, when this page loads, it'll be autofocused. As you can see when I refresh, if I start typing an email address, it's invalid. But when I type a valid one, boom, the CSS selector kicks in. Telephone numbers, URLs, you can do things like patterns. You can do regexes. So if this certain field meets this regex, it'll be valid or invalid. That's really, really handy. Again, no JavaScript. Date pickers. You saw the file ones in the keynote, so you can select a directory. You can do directory upload now. You can do things like speech input. You can select multiple files, so there's no more, if you have a bunch of, if thumbnail gallery, for instance, you don't have a bunch of file inputs, you just have one. You can upload an entire directory of photos. The last couple ones here are kind of undercover and still being implemented in a lot of browsers, but the WebKit browsers, so that's Chrome and Safari and iPhone, have these implemented. There's a new meter tag and there's a progress tag, and these are pretty cool because, again, we've been using widget libraries like jQuery UI for a long time. And instead, we can just render this stuff natively just by setting a value, setting a min-max parameter. And one really nice thing about this tag is that there's fallback. So you can see that if the browser doesn't support the meter tag, they're just going to get a value of A+ for a grade. Same with the progress tag. So they'll get 75% is complete rather than this nice UI, but it's a great for a fallback case. So let's sort of switch gears now and talk about web storage and some things you can do with taking your app offline. We're a mobile society now, and you want to access your data anywhere and have a really performant app, no matter if it's on a device or a browser. So there's really three options when it comes to the web storage APIs. And that's local storage, a thing called session storage, and a thing called WebSQL database. And local storage and session storage are very similar. Local storage is just a key value pair. So you see in this example here, I'm calling the local storage global object in JavaScript. I'm setting a date of birth to my birthday. It's just a string value, so a key string pair. You can delete that if you want. A clever technique is if you want to store more complex data, you could actually use the native JSON.stringify to stringify an object, and then on retrieval, suck that back out of local storage and parse that into an object again. Session storage is the same way, key value pairs. The only difference is it's for things like sensitive data, maybe a banking session. At the end of the user's browser, when they close the tab, all that data will be erased and deleted. The last one here is WebSQL database, and there's nothing new here. If you've ever written back into a web app using SQL, something like PHP or something, it's basically SQL in the browser, SQL in JavaScript, and I'll show you some examples. By default, you get 5 megabytes persistent storage, and so when the user closes that browser and opens your app again, you'll have the same data that's stored in the database, which is really nice. So basically, it reduces round trips to the server. This is something that the mobile app of Gmail uses, to cache your data, so you can have the availability of your email offline. And here's what it looks like, and I apologize if you can't read that in the back. But basically, I'm just setting up a global namespace, a WebDB object, and then setting a bunch of event handlers for each of these processes. So the first one here is just the open method. We'll call webdatabase.open to create this database, call the open database method. We'll give it a title, we'll give it a version, a description, and a size. In this case, we'll just say 5 megabytes. 2 event handlers, one for error conditions, one for success conditions. And then the rest of this is sort of nothing new. Everything is wrapped in a transaction, a database transaction. So it either succeeds or none of it does. And then you just execute SQL directly. So again, it should look pretty familiar to you if you're familiar with SQL. So I did lie. There's actually a fourth storage option that just sort of came online. It's called IndexedDB. And IndexedDB is a sort of a hybrid between local storage and session storage and WebSQL database. So you have in-order retrieval, but you have things like fast search, and you can do queries over it. It just landed in Chrome, in fact, in Chromium, which is the open source version of Chrome, as a prefix with WebKit IndexedDB, so you can feel free to start testing it and developing on it. Firefox 4 has it implemented as well, so look for this in the future. This is an exciting new storage option that could take off. So along the same lines of web storage and making an app performant, there's a thing called application cache that can help along that line as well. An application cache is really designed to take your application offline. So you can explicitly say, I have JavaScript, I have CSS, I have HTML files. I want to cache these and make this whole app, or portions of it, available to my users when they don't have an internet connection. So this sort of, goes along with browser caching, right? Browser does automatic caching, but it's not really reliable all the time. And as a developer, you really don't have a say on when things are cached and what is cached. It kind of just happens magically in the background, and you're not guaranteed to have something cached. So application cache is a way around this. It's also good for not only storing data offline, but making the app more speedy. So when you load up your app for the first time, if it's pulling from the data, the local storage of the application cache, it's going to be faster on boot than making that network request. So implementing application cache is actually really easy. Basically, you just have a manifest, and you set the manifest to the name of a file. And that file is just basically a text file. Certain points in the text file. So there's a cache manifest line is the first line of that file. And then below that are the things you want to explicitly call out to be cached in your offline experience. So there's a cache label. You can see I've just listed a few files here. I've listed the main page itself. I've listed a style sheet of the page, maybe a logo, maybe some JavaScript. And these things are going to be available offline to my users. There's a fallback section. So in this case, anytime somebody hits the root of my site, I'll just serve them a static.html page. And lastly, there's a network portion. So things like a login script or things like a Twitter API call or some kind of API call will need network access, and you won't be able to use that functionality offline. So there's this place for that, saying that I absolutely need these things to be online. Of course, with everything, it's got a JavaScript API. Application cache is a little hard to debug, and that's because if one file fails to be fetched from the browser as it goes through this process of updating the cache, the whole thing kind of fails. But the good news is that we have pretty much events for pretty much everything. So you can see when things are cached, when it's checking for new files, when it's downloading the files, when there's an error. And then you can see at the top here that we have the global object window.application cache to access these methods and APIs. You can programmatically, when it's ready, when it's ready to update, you can programmatically swap in a new cache if, let's say, you've uploaded a different version of your site since the users last visited it. I mentioned it was a little hard to debug, and I just want to throw out a quick shout out to the Chrome developer tools, because the team has done a great job in incorporating different aspects of APIs. So one really nice thing about the application cache, if you visit an app that uses this, it'll actually print a bunch of log messages out in the console showing you which files it's downloading, and so you can see sort of where things are failing, if they are failing, what the progress is of the whole cache. There's also that about app cache internals URL that you can hit in the browser URL, and you can delete the application caches if you're debugging the site. So that's a lot of stuff. Let me just show a quick demo. If I have internet. There we go. So this is my stopwatch app. It's not very exciting. There's not a lot of styling going on here. But it's simple, right? It starts, it stops, it does what it's supposed to. If I fire up the dev tools, and just hit refresh, you can see that I've already, the application cache is already loaded from this. So there's no update available. That means I've already visited this site. The app cache has done its magic. And all these files are being served to me locally. I'll also note that in the storage panel of the DevTools, you can go in and actually examine which files are cached. The size, when they were last cached, and everything. Pretty nice tool to have. So the beauty of this, and I'm not gonna shut down my Wi-Fi right now in fear that I won't get it back. But the beauty of this is that the app cache is in work. So I can go. Sorry, this is a little difficult to do from the side. Oops. I can view the page source and see at the top of this file that we're actually using the manifest file. And just to show you. Show you what the manifest file looks like. So it's really simple, right? There's that cache line that we talked about. It's caching the main page itself, the CSS and JavaScript of that page. So let's talk about web workers. Web workers are sort of a paradigm shift in JavaScript. If you're familiar with JavaScript, at least inside the browser, JavaScript is a single threaded process inside the browser. So you're doing one thing over here, maybe you're updating a UI over here, and then you have some big computation happening over here. It's got to wait, so it's blocking. And web workers really gets around that. We have these really fast machines these days with multi-core processors, and we can't take advantage of that in our applications until now. So we can take advantage using web workers. And some use cases here might be something like text formatting a long document, or code syntax highlighting. For instance, code.google.com has code snippets that are highlighted. If you had a bunch of that, and you're adding divs and spans and classes for everything, that's going to take a little bit of time to do in raw JavaScript. Another great example is the audio data API, which is something Firefox has implemented. You can actually manipulate audio data and create audio data on the fly. And so something like a web worker, when you're spawning a multiple process to deal with that computation, is a great example. Same thing with image processing, same thing with processing large arrays. So if you're familiar with the CORS, cross-origin resource sharing model in HTML5, it's pretty simple. It's just a message passing system. So the first thing you do is create a web worker, and the URL there is the file with the worker code in it, which is this portion at the bottom here. But this is our main page at the top, so it's our HTML, it's our main JavaScript. We'll create the worker, and we'll set an onMessage event handler for this worker. So anytime the worker responds with data, we'll just catch that event and then log it to the output div there, or output tag, excuse me. And to start this, we'll just call worker.postMessage with the command. And in this case, I specify the command as a start argument. And our worker code is going to do all the work for us. So this is going to fire up a separate process in Chrome. You can do things like import scripts. So maybe you have a library that you want to use. You can call the import scripts method with different arguments. And then we do the same thing in the worker code that we did in the main thread, which is just to create and handle a message event. This is a kind of nice example because we have one event listener to handle multiple commands. So I passed the start command in the first example here. And then similar to what you saw with Ernest's Chrome extension, you can switch on the different command and then do something accordingly. So this isn't a very good example of a worker, granted. It doesn't do anything intensive, but it just echoes the data, or it echoes some data. Maybe you're making a request or an XHR request to an API or a bunch of APIs and then sending that back. A cool little trick with some more HTML5 features is you don't need a separate file for workers anymore. So you can use the blob builder API along with the create object URL, which is something very new in like tip of tree Chromium. So instead of having a separate file for my worker code, I can embed the code within the page itself. And the magic happens in that top line there, that script tag. But you notice the type is equal to text HTML instead of text JavaScript. So the browser's not going to render this or process this as JavaScript. But that's my worker code in there. And what I'm doing is I'm creating a blob builder. I'm querying that script tag. I'm getting the inner text of that script tag and appending that into the blob builder. I'm getting the blob and using create object URL, you can create a temporary reference, a URL to that blob that you just created, and passing that off to my worker. So instead of a hard-coded file name, I'm just using the inner text, which is a pretty cool trick, I think. So if you want something self-contained, this is the option for you. So another thing you can do with performance is WebSockets in HTML5. And that's really for communication purposes. So we have, for years we've been doing things like long polling and XHRs and hanging gets and all this stuff. And these are all basically hacks around, push events. But what we have now are things called WebSockets. So this is bidirectional communication between client and server. It opens up a connection over a TCP-like socket. Over HTTP, there's port 80 and there's SSL versions. And basically you just talk to this server, it opens a connection for lifetime, and each end can sort of push data to each other. They don't have to request, so there's no request and response, there's just push. So you can imagine a chat room, you can imagine a whiteboarding application, which I'll show you, and games is another great example. So multiplayer games is perfect for WebSockets. So again, there's a JavaScript API for this. It's pretty straightforward. You just create a new WebSocket object, reference the server that you're talking to with the WebSockets prefix, the WS prefix. And then you define 3 methods for event handling. So there's an open method, there's an on message, and there's a close. And we'll just call the WS send method to send something. WebSocket will do something on the server and send us data back. So let me show you an example of this. This is actually a pretty nice demo because, so this is using the canvas tag and WebSockets to have multi sort of player whiteboarding capabilities. So unfortunately, I don't see anybody else logged in. If you have laptops and you want to log in and start drawing, we can see you real time sort of draw something. But there we go. There's somebody. So we're all connected to this application, and it's in real time. I assure you, if you were sitting right next to the person, it is pretty much real time, which is pretty exciting. There's also a chat room here, so you can chat on the side. So maybe I'll leave this up for a while, and as I continue presenting and see what people come up with. Who's 354? Anybody? Maybe it's not somebody here. But just a great example. So the real-time communication is very much possible in HTML5. I want to quickly give a shout out to another feature called server-side events. Server-sent events. These are sort of less known and a little bit older than WebSockets, but they're also very useful. And server-sent events are different from WebSockets in that in server-side events you're only pushing data from the server to the client, but they're push notifications. They're not sort of a request response. And some use cases, maybe you have a stock ticker application that wants to push updates in real time. A news ticker, a friend status update. Just a different use case than WebSockets, but also very valuable. I'll show you some quick code, both client and server, and then we'll see a demo of this. So this is also very simple, similar to WebSockets. You just call a new event source with the script that you're talking to, the server script that you're talking to, events.php in my case. And then we'll listen for messages. We'll have an open handler. And we'll have an error handler. And in this case, we'll just log what the server is responding with. So we'll log the message that were echoed. The server itself is pretty simple. It's just a few lines of PHP. First thing I need to do is serve as a MIME type text event stream. I'll have a send method that'll just take an ID and a message. And this is the format of the event that you need to send. It's ID, and then a new line, data, the data you're sending, a new line, and then another new line. And then I'll just flush that data because I want that data to be echoed immediately when it's available. And then I just have this do while loop. So you notice that it's an infinite loop because I want to keep the connection open. So every 3 seconds here, I'll send a new message using my send message, and I'll just send the server's timestamp. So let me show you what that looks like. Perfect. I lost. What's my mouse? All right, there we go. So I have event handlers for all this stuff. I have an event handler that shows me a connection status. I'm just displaying a nice little UI there to show that I'm connected to the server. We saw that connection was open. I'm sent an ID. I'm sent the server's timestamp. And so every 3 seconds, you're noticing that the connection is being closed and open again. And I'm not doing anything special for that. That's something that's handled by the browser. That's something that's handled by the specification. So it's basically doing polling every 3 seconds. But if you look at the resource manager in the developer tools, you can see that 3 seconds, we're making a new request. So by making a quick change to the sorry, you can't see that. This is the PHP that I just showed you. And I'm just going to change the condition of the while loop to false. Oops. This is impossible. So now you notice the connection is being open and closed much more rapidly because we don't have that do while to keep the connection open. So instead, the browser, what it's doing is just pulling it by itself. But we didn't do anything. We didn't do any event handling. To do that, it's just happening in the background at Magic. So that's pretty cool. Of course, you can close the connection using the API itself. So last section, I want to talk about our sort of tools and compatibility for HTML5. There's a lot of great things out there. There's a lot of resources coming online every day. I want to call out a few that you should know about when developing an app. The first one is the Google Fonts API, which is something that we announced at Google I/O. And this is fantastic because this has just a complete list, and it's getting bigger every day, of free, beautiful web fonts that you can use within your application. So imagine a site like this, right? This is a site probably from 1993. And there's not a lot going on here, right? There's no CSS, there's just links, and that's basically what the web was, 10 years ago. But with the Fonts API and CSS3, I can really make this new site, shine. The first thing you'll notice is the logo. The logo is not, an image. It's actually text. So that's selectable. That's crawlable by search engines. It's indexable, which is great. People can find what they're looking for. I can use CSS columns to lay this out in a magazine or news type feel. And then you have other things like semantic tags. You don't actually see those on this particular image, but more descriptive markup. And the way to do this using the Fonts API is very, very simple. So it's literally just including a reference to a CSS file. So I'm calling the Google Fonts API with a couple of fonts separated by a pipe character. And then you just embed this on your page using CSS normally. So you reference the font name, Tangerine, there in my H1. So every H1 on this page, after the font has been downloaded from the API, will look beautiful. So making the web beautiful again. Just want to show you a quick demo of this in action. Let's see if this loads up. So this is the Chilean government's website. And what they're using is the Fonts API. So you'll notice, for example, that I can select these beautiful fonts. This is all fonts. These menu options are fonts as well. But the really cool and I think successful part of this is that in Chrome, right, you have this little bar that pops down to say, do you want to translate this text? So when I do that, when I translate it, all the fonts, all the beautiful web fonts on the page turn to English. So it's not only for accessibility and discoverability, but you can do cool things like that. And this is something you couldn't do with, say, a background image or a flash, for example. So if you're worried that HTML5 hasn't arrived yet, I would agree with you. It's not there for everyone, especially users of IE6, for example. But there's something you can do, and it's called a tool. It's a plugin called Chrome Frame. If you're worried about IE6, 7, and 8, and you don't want to spend extra development cycles developing and hacking around to these browsers, you can install Google Chrome Frame, or users can install that. And what that does is it basically renders inside of IE. It renders Chrome. So users get things like geolocation and CSS3 using the Chrome rendering engine, using V8, using the CSS layout, basically Chrome inside of IE6. So it's fast and performant, secure. And it's really easy to use. So as a developer, all you have to do is include a meta tag on your site or optionally send a header. And that's all that needs to happen. If they have the plugin installed, it'll just work. Your site won't look terrible in other browsers. There's the developer tools, which definitely have an hour worth of talk, should have an hour worth dedicated to them. Unfortunately, I won't cover too much of them today. I showed you a little bit. But the idea here is that you really can develop a web app, at least the client side of a web app, in the developer tools. So you can do things like change CSS values. If you're familiar with Firebug, you can do that same thing within Chrome developer tools. It's really an invaluable resource. There's HTML5 rocks, which I'm particularly proud of. Ernest and I both work on the site. There's a bunch of tutorials there. If you're curious in any of these APIs, we have presentations, cool interactive presentation, all written in HTML5. There's also a code playground, so you can start experimenting with these different JavaScript APIs on the fly. So do check that out. So is HTML5 ready? I would say it is. And if you're still unsure, there's a bunch of different resources you can check. So caniuse.com. You can search on any available API pretty much in the specification to see which exact browser versions are supported, which is really handy when developing something. There's Modernizer. So Modernizer is a great library that does feature detection and not user agent detection. So oftentimes users will modify their user agent, so that's unreliable. Whereas feature detection, does the browser support WebSockets? Does it support any of these features, WebSQL database, IndexedDB. And so what you get back is you get back a global JavaScript object with a Boolean value, true or false, is web workers available, which is really handy. And this is sort of what that looks like. So if I'm on a page, for instance, and I'm in IE6, which doesn't support the audio tag, I have some audio markup with a couple MP3s, or with an MP3 and an OGG file. And then what I can do is I can check the modernizer.audio property to say, is audio available in this browser? If it's not, of course that'll be false. And then I can display some CSS to hide that audio tag based on if that feature is available or not. So it's important to do feature detection and not user agent detection. So that's sort of it. I know there's a sort of a lot of different information there. Feel free to come up and ask me questions, or ask me questions now. These are the links, HTML5 rocks, the compatibility stuff. Please, 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 if you do find a bug in Chrome or Chrome Developer Channel or any of these browsers that are not stable yet, do let us know, because this is the way the features get prioritized and bugs get fixed. And you as developers are the ones that we listen to the most. Feel free to follow us on Twitter at ChromiumDev, and there's the last link if you want to discuss anything related to HTML5. So I'll keep that up for a second because I see people taking photos. Okay, I'm sorry, I'm being cut off. I have to. If you want to come talk to me, feel free to come up here and chat.